Hi there, Bentley. Zen Miller for assignment number 9 here on the power transmission on the grid. Going to just start with kind of what the power is being created by the nuclear power plant, wind turbine in our case, or coal fire, whatever we have. So when we make that power, we're going to have to get it onto the transmission lines to get it into the grid. Now, in order to do that, we step up the voltage on it for reason of creating less current by raising that voltage up to transmit it over long distances over the transmission lines. Now, that drop in current creates less heat, less power loss is the reason that I really understand why we do it. And we're taking it up to hundreds of thousands of volts is the readings that I've been doing recently on our power transmissions. Now, the kind of pathway or roadmap, if we look at it, depending on which grid that we're in, I know there's 3 different sections across the U.S. the west, central, east, and then there's all these other small grid systems tied in or connected to each other, run by different utility companies, electric companies, stuff like that. So if I was going to show you my cheesy little diagram here, we have our power supply. It's going to take it to the transformer, step it up to the substation. From the substation, it's going to bring it up in voltage in 3-phase 60 hertz onto the transmission lines. Depending on what that distance is that it's transmitting the electricity to, it's going to depend if we're going 100 miles, 20 miles, or even 1 mile. It wouldn't have to step it up that much. Again, the only reason we're doing this is to save electricity and become more efficient, as a lot of electricity gets lost in the transmission lines. So we bring it up to high voltage, then we drop it back down at substations closer to the end user, depending what the electrical demand is, how far from the actual grid it is. It might be 7,000, 8,000 volts going out to further distances from the actual main grid itself. Now, what I understand, the grid is becoming more of interactive between the supplier of the power that's actually sending it onto the grid and the end user, and allowing electrical companies and the people that are monitoring what's happening in the grid to understand if we're losing more power, gaining more power, how to regulate exactly what we're losing or the peak times for our users, or that they can predict when the best time is to kind of grab power from certain areas or to slow down our power output or create a capacity for it. This is my general kind of knowledge that I've learned so far into our power usage, transmissions with the grid, and how we're becoming better at not only saving energy but being able to recognize the difference in wasting and using as well. And this is basically where I'm at right now for understanding the transmission lines and the grid system at this point.